So hi, hello everyone. Today we are moving into a bit of geography basically. So let's just go and have a look into a very important chapter, that is the universe and the solar system. And basically this topic is also like covered in the in any kind of an examinations, not like only for competitive examinations and all. This is something that is very important for any kind of information and also for general knowledge and all. So let's today just begin the video then, and let's just move into the topic directly without wasting any further time. So the first topic, first the chapter is like the universe and the solar system, right? So what is the universe? We know like universe is our entire, means we live in this universe, right? Earth is one of the planet in this universe. So that is what, and sun is the uh, means we are all orbiting around the sun. We are all moving, means the other planets are all moving around the sun. So the universe is the sum total of all potentially knowable objects. The study of universe on a grand scale is called cosmology. It is also called cosmology. And the universe is including planets, stars, galaxies, and the intergalactic space, the smallest subatomic particles, and all matter and energy, right? So these are all including in our universe, means planets, stars, galaxies, and intergalactic space and everything. So let's just move directly into the, and what is like cosmology. When a study of universe on a grand scale, it is called cosmology. When it is done in a larger context, when it is done in a grand scale, bigger scale, then it is called cosmology. So all the heavenly bodies, that is stars, planets, satellites, asteroids, meteors, comets, dust and gas, are called celestial bodies, and is known as astronomy, right? So this is all celestial. These are all celestial bodies which together form the universe. And heavenly bodies, and the study of heavenly bodies is known as the study of heavenly bodies. This study is particularly known as astronomy, right? This is the astronomy, and the scientists who practice astronomy is called astronomers. Practice those who study about astronomy, and they are called astronomers. This is where it is marked. Now theories about universe. So theories about universe, like universe fascinating since ancient times, and there have been multiple theories. The early theory is like geocentric theory. What is the geocentric theory? Geocentric theory is basically proposed by Ptolemy, and in AD 140 it was proposed, which states the Earth is at the center of the universe. That time around it was mentioned like Earth is at the center of the universe. It was like that time it was mentioned. And now it is the heliocentric theory. Heliocentric theory is something where the theory is like in 1543 AD, and it is like mentioned the sun is at the center of the universe. So that way around, like when it is a heliocentric theory is coming up, it is mentioned like the theory is proposed that it is uh, sun is at the center of the universe, right? Now in 1805, British astronomers Herschel studied universe with the help of telescope and stated that solar system is merely a small part of a galaxy. That time around, the first concept of like solar system was given, that we are like a it is a entirely, it is a galaxy, and the universe is in this galaxy only, and it was done by British astronomer Herschel, right? Now, in American astronomer Edwin P. Hubble in 1925 said that universe has a diameter of 2.5 billion light years and is composed of several galaxies. So that time around, it was mentioned like universe is like a diameter of 2.5 billion light years. It is the total diameter, means that the universe diameter is 2.5 billion light years, and it was mentioned by Edwin P. Hubble in 1925. He was an American astrologer, right? And now at present there are modern theories. Modern theories, like there are four main modern theories put forward to explain the origin and evolution of the universe. So this is something like at present there are four modern theories. And what are those modern theories? We will be looking into it like from here. So first is the Big Bang theory. The Big Bang theory is the most acclaimed theory proposed by Georges Lemaitre in 1930s, and later strongly evidenced by George Gamow, which explained the modern Big Bang theory. So this Big Bang theory is something like which is the presently uh, uh, this theory is uh, basically something that we are all believing, right? So this is the theory that we are all basically uh, at present believing. So in this theory, it is mentioned like that it all started like from a single point, and after that a major explosion took place and all, and that way around like the universe was created. Like um, it was a huge amount of energy, and then this conversion of mass and everything happened. So basically, this is the concept of Big Bang theory. So now we will move into the details what is mentioned over here. The theory states that at the beginning all matters forming the universe existed in one place in the form of a tiny ball, singular or primeval atom with an unimaginably small volume, infinite temperature and indefinite density, right? Indefinite density. So that is what I was mentioning, like it was like a small point that was being at that time the theory states that at the beginning it was like in a tiny ball, singular primeval atom, and unimaginably small volume, infinite temperature, and infinite indefinite density. There was a huge small volume was the volume was very less, but there was an infinite temperature and indefinite density. So around 15 billion years ago, it was like around 15 billion years ago, vast explosion occurred, and the primeval atom and the expansion of the universe that still continues till today and will be further. So that 15 billion years ago, that huge explosion that took place, and that huge explosion basically started the expansion of universe and still continues to till today and will be further. It will continue like this, right? So the expansion of matters further formed, the expansion of matters further formed galaxies, and those galaxies are continuously expanding and moving away from each other in an accelerated velocity, and the process and in the process cooling the universe. So also like mentioned, like the expansion of matters further formed galaxies means these formed galaxies, and these are expanding in an accelerated velocity, and the process is cooling the universe. Now the Big Bang theory or the accelerated velocity, the Big Bang or the expanding universe is now proven by the discovery of the cosmic microwave background radiation (CMBR) and the Wilkinson microwave anisotropy probe. Right? This is like present day. These are the two things that way around. This is proved. Like Big Bang theory or the expanding universe is now proven by the discovery of the cosmic microwave background radiation. Cosmic microwave background radiation, and there is also Wilkinson microwave uh, anisotropy probe. So these are the currently proven by these scientific means these technologies are proven, right? So and another important astronomical observation called redshift also proved the expansion of the universe. Like this way around, the redshift also is proving the expansion of the universe. The redshift is also this is observation, and the redshift, right? The redshift is basically it is proving the expansion of the universe. The recent experiments are all at the Large Hadron Collider (LHC) built by the European Organization for Nuclear Research beneath the Franco-Swiss border near Geneva, Switzerland, aims to uh, recreate conditions just after the Big Bang to have a better understanding of the phenomena. So there are like presently all these new experiments and all these are also being conducted, right? So these experiments and these everything like which is mentioned over here is also conducted like research beneath the Franco-Swiss border near Geneva, Switzerland, aims to recreate conditions just after the Big Bang to uh, have a better understanding of the phenomenon. And similar kind of a setup of like Big Bang is being created by scientists so that it all this could be more better means explained and all. These have been recent experiments like these are like Large Hadron Collider (LHC). This is the place where these experiments are done, and it is built by Europeans Organization for Nuclear Research beneath the Franco-Swiss border, which is in Geneva, Switzerland. So now, like we are coming into the next part. So the next part, it is like redshift theory. So this redshift theory, it is basically light is formed of a band of colors called spectrum. We all know this means means there is this particular means band of colors which are from which means we are like uh, being able to see particular colors that are like processed by our eyes and all, but there is a particular spectrum which we find in a rainbow and all, right? So violet color has the shortest wavelength. Shortest wavelength is of violet, and this is like lies at the end of the spectrum. This violet lies at the end of the spectrum, and red light has the longest wavelength. Red light has the longest wavelength. So this red light has the longest wavelength, and the shortest wavelength is of violet. Violet lies at the end of the spectrum, and red light has the longest wavelength, and red light lies at the other end. Like it is like not at the end, so it is like in another end. The red light is in another end, right? the movement of a star or galaxy affects its light as seen by the observer. When the star is approaching the observer, the light shifts to the blue end of the spectrum, and the light shifts to the red, and when the star recedes away. Like these are movement of star and galaxy effects. So these are observed, and when a star is approaching to the observer, means the light shifts to the blue. The light is shifting towards the blue spectrum, the blue end of the spectrum, and the light shifts to the red end when the star recedes away. So that way around we see the bit of means red when the sun is when the star is finally receding, means the star is not going to stay in this means our visibility after that, and when it is visible, that it is we are seeing it as a blue coming as it is shifting towards the blue end of the spectrum, and this is known as Doppler effect or Doppler shift. The Doppler shift of the galaxies shows that they are receding and that the universe is in a state of rapid and accelerated rate of expansion. This astronomical observation is known as redshift. This is what is known as redshift, and this is called redshift. So that way around it is also proven, like we are basically the universe is accelerating and at a means it is expanding basically in an accelerated rate of speed, and this is what is Doppler effect or Doppler shift, right? Doppler effect or Doppler shift is this. The Doppler shift of the galaxies, that is what is proving that there is a major expansion. It is happening in an accelerated rate, right? So steady state theory. So steady state theory, this is like Bondi, Gould, and Fred Hoyle developed this theory. According to this theory, the number of galaxies in the observable universe is constant, and new galaxies are continuously being created out of empty space. So that way around it is proven, like by the Bondi, Gould, and Fred Hoyle. This is the these are they are the astronomers who basically developed this theory. So according to this theory, the number of galaxies in the observable universe is constant. So they are mentioning like the the number of galaxies are constant, and new galaxies are continuously being created out of empty space. Means out of empty space, new galaxies are being created, and this is something that is filling up the gaps caused by those galaxies which have crossed the boundary of the observable universe. Means there is also gaps being created, and these gaps are being crossed the boundary of the observable universe. Means these have crossed the boundary of the universe that we are being presently observing. So because of the new galaxies that are being continuously being created out of the empty space, so these boundaries have been crossed, and as a result of it, the overall size of mass of the observable universe remains constant. So that way around it is says that the observable universe remains constant, right? Thus a steady state of the universe is not disturbed at all. So this way around, this is mentioning like steady state theory, it is not disturbed at all. The steady state is not disturbed that way, right? And pulsating theory, according to this theory, the universe is supposed to be expanding and contracting alternatively. That is pulsating. Means they are mentioning like it is also expanding and contracting just like a pulsating kind of in a pulsating manner. And at present the universe is expanding. It is mentioning like at present the universe is basically expanding. According to pulsating theory, it is possible that at a certain time the expansion of the universe may be stopped by the gravitational pull, and it may contract again. So they are mentioning like it can be like a means at present it is expanding, but it can also contract also. It can also shrink after a certain time, and after it has been contracted to a certain size, explosion again occurs and the universe will start expanding. Means after it will contract, then there will be again explosion, and that explosion will be basically again it will be making the universe to expand. The alternate expansion and contraction of universe give rise to pulsating universe. That is how what is this theory is basically. That is how this pulsating universe concept is coming. And now the age of the universe, like the astronomers estimated that the Big Bang occurred between 12 and 14 billion years ago, and the age of the universe is now around 13.7 billion. Means it is mentioned to be like 13.7 billion years on the basis of measurements made on the cosmic microwave background radiation CMBR. Our solar system is thought to be 4.5 billion years old. So like the entire universe is like 13.7 billion years ago it was created, and our solar system, the system that our planet Earth is also into the solar system, so that is thought to be like 4.5 billion years old, right? Now astronomers estimate the age of the universe in two ways. By observation made on global clusters, which are dense collection of roughly a million stars having many old stars. And another one is by measuring the rate of expansion of the universe called Hubble constant and extrapolating back to the Big Bang, right? So this way around, the age of the universe is also determined. And like then we are coming into this part. So if the pressure of the matter is low, then the fate of the here you have something written, so that is being covered by the layout of the video. So let's just the rate of expansion is expressed by the Hubble constant, while the strength of gravity depends on the density and the pressure of the matter in the universe. If the pressure of the matter is low, then the rate of the universe is governed by the density. If the density of the universe is less, then the critical density, which is proportional to the square of the Hubble constant, then the universe will expand forever. So if the density of the universe is greater than the critical density, then the gravity will eventually win and the universe will collapse back on itself, which is called the Big Crunch, right? This strange form of matter is now returned as referred as dark energy. If dark energy in fact plays a significant role in the evolution of the universe, then in all likelihood the universe will continue to expand forever. So these are the concepts, right? Basically, we are like in a means conclusion that universe is expanding. The universe will keep expanding, and that is what is being believed, and that is what is being proven. Now, components of the universe. Our universe has a foamy structure. Considering only the largest structure, the visible universe is made up of filaments, super clusters, and galaxy groups and clusters. The galaxy groups and clusters in combined form are called super clusters. Means the galaxy and clusters, these are combined and they are called super clusters, which are on turn form part of the worlds, which are also part of filaments. The visible part of universe is concentrated in certain parts in a complex scaffold that surrounds a network of enormous cosmic voids or vast empty spaces. These things are like mentioned over here. We know that there are enormous cosmic voids or vast empty spaces. Visible part of the universe, scientists have discovered that there are vast amount of unseen matters called dark matters. Like there are vast means we know that there are huge amount of unseen parts and unseen matters which are called dark matters. So dark energy, this is in proportion that is mentioned, like dark energy 68%, dark matter is 27%, visible matter is 5%. The visible matter of the universe, like now coming to the visible matter part, now this visible matter is like hydrogen, it is 72 to 75%, helium is 23 to 26%, and other elements are like less than 2%, right? Other elements are like less than 2%. This is the portion which is mentioned over here. The visible matter is important, like hydrogen is like 72 to 75%, helium is 23 to 26%, and other elements are like 2%. So major component of our universe is basically hydrogen, right? And helium is like also the next component, which is 23 to 26%. The process of nuclear fission has very slightly increased the quantities of helium, but the proportion composition is practically unchanged since the earliest year of the universe. Like the components are more or less they are remaining the same. There is no change in the components also, right? And dark matters cannot be seen by any of the electromagnetic spectrum such as radio waves. The dark matters could not be seen by radio waves, X-ray, etc. But certain phenomena such as gravitational lensing, temperature distribution, orbital velocities, and rotational speed of galaxies, etc., evidence of missing mass and justify the probable existence of dark matter. Another invisible entity known as dark energy is believed to be the reason why galaxies are speeding away at an accelerated rate. So another invisible entity is like dark energy. The dark energy and dark matter, these are not that much possible to like be means observed and all, but that is what is mentioned in this point, right? We have that basic concept at till now. Now we are coming into this means galaxy part, right? So galaxy, this galaxy, a large group of stars is called galaxy. We know this large group of stars is a galaxy. There are billions of galaxies having different sizes, regular and irregular shape. Galaxies can be divided into two categories. Large group of stars is basically called galaxy, right? Normal galaxies, these galaxies emit comparatively small amount of radio radiations as compared to the total radiations emitted. These galaxies are bright from the center and gradually dim towards the edges. Each normal galaxy contains billions of stars in the form of a band traveling towards in the universe. Depending upon their shape, the normal galaxies may be divided into three groups namely. So normal galaxies can be divided into three groups basically, right? Into three groups we can divide it. Number one is elliptical galaxy, and next is like spiral galaxy, next one is spiral galaxy, and the third one is like irregular galaxy. Elliptical galaxy, spiral galaxy, and irregular galaxy. And about 18% of the galaxies are elliptical, 80% of the galaxies are spiral, and only 2% of galaxies are irregular galaxies. So 18% galaxies are elliptical, basically 80% of galaxies are like spiral. So these are shapes. So we know that elliptical is a different shape, spiral is a different shape, and only 2% are like irregular galaxies. The irregular galaxies are youngest, spiral galaxies are middle-aged, and elliptical galaxies are quite old. And radio galaxies, these galaxies emit million at times more radio radiations than normal galaxies, and there are like 170 billion galaxies in the observable universe. The largest galaxies have nearly 400 billion stars, and our galaxy Milky Way has about 100 billion stars. Like we are into this, our galaxy means our galaxy is called Milky Way, that has like 100 billion stars in this Milky Way, right? So Milky Way, it is the name of the galaxy to which our Earth belongs. If one looks at the sky on a clear night, a hazy band of white light stretching across a great circle is seen, which is called the Milky Way or Akashganga. It is a spiral galaxy, and recently a supermassive black hole known as the Sagittarius found in the core of the Milky Way. Right. So this one new uh, means black hole has been found. It is called Sagittarius A, found in the core of the Milky Way, and this is what we can also see like in a clear night, a hazy band of white light which is stretching across a great circle, right? Now stars, what is star? The star is a fiery luminous heavenly body that has own light and heat energy. Sun is nearest to our planet Earth, and it takes 8.3 minutes 500 seconds for light to reach Earth from Sun. Proxima Centauri is the nearest star beyond our solar system, that is at a distance of 4.3 light years from the Earth. So this is what is the means Proxima Centauri is the nearest star which is beyond our solar system, to the after our solar system, and that is at 4.3 light years away from the Earth. So we have already discussed like, and we know also like these are all measured in like light years and all. And stars may exist as a single star, but a very few in the universe, only 25%. They may also occur in pairs called binary stars. About 33%, the rest are multiple stars. Alpha Centauri consists of 3 stars. So there is like this which we have mentioned earlier, like Alpha Centauri. This is like uh, basically there are 3 stars in Alpha Centauri, and variable stars are also stars that show varying degrees of luminosity. Luminosity fluctuates between periods. Delta Cephei is an example. Stars of fluctuating luminosity are called Cepheid variables, right? So which the stars which are having this fluctuating luminosity, we see sometimes like some we see this twinkling and all. So these are called Cepheid variables, right? And now coming to the next part, like uh, electromagnetic wave of very short duration, and that is whereas the uh, pressure of the matter is low, and then the rate of the universe is governed by the density. So if the density of the universe is less than the critical density, which is proportional to the square of the Hubble constant, then the universe will expand forever. And these things we have discussed. So we'll now move to the next part, like here. Yes. So stars form when enough dust and means how stars are created. Stars are formed when enough dust and gas clump together uh, because of gravitational forces, nuclear reactions in and like small amount of gravitational means smaller amount of dust and gas clumps there comes together because of the gravity, right? Stars like the sun change their own form into other forms of stars such as red giants. The sun is also a star, and they form into other forms like red giants, white dwarfs, neutron stars, and black holes during their lifetime. Means these are the lifetimes, because when a star is like created at the initial point, it is a red giant, right? It is the concept at present. Like first it will become a red giant, then it will become a white dwarf, and then after then then it will become a neutron star, and finally at the end it will become a black hole, right? The fate of the star depends upon how much matter it contains, and this fate is decided upon means how much matter is there in the star. High mass stars are much brighter than low mass star, thus they rapidly burn through their supply of hydrogen fuel. A star has enough fuel in its core to burn it, which makes it bright. Example, the sun has enough fuel to keep it bright for approximately 9 billion years. So this one is like mentioned over here. So that is why the sun is always like shining and always like burning and all. A star that is twice as massive as the sun will burn through its fuel supply in only 800 million years. 10 solar mass star, that is 10 times more massive than the sun, burns nearly 1,000 times brighter and has only 20 million years fuel supply. Conversely, a star that is half as massive as the sun burns slowly enough for its fuel to last more than 20 billion years. Life cycle of a star, that is what I was mentioning earlier, means life cycle of a star are born in nebula. A nebula is a cloud of gas of hydrogen, and so this is from which a star is developed, means created, which is a nebula. It's a cloud of gas of hydrogen and dust in space, hydrogen and dust. Huge clouds of dust and gas collapse under the gravitational force, forming protostars. These young stars undergo further collapse, forming main sequence stars. Right? Stars expand as they grow old. We all know the means universe expanding. That way, stars also are expanding and all. As the core runs out of hydrogen and then helium, the core contracts. Means once the hydrogen and helium is like used and all, the core is contracting and the outer layer is expanding. Outer layer is expanding, cool and become less bright. So this is a red giant or a red supergiant depending on the initial mass of the star. This phenomenon is like red giant or red supergiant. It will eventually collapse and explode, then become either a black dwarf, neutron star, or a black hole. Right. So that way around, that is what I was mentioning. So first it will be a red giant, and then it depends upon the mass it has. Then it will be converting into a black dwarf or a neutron star or a black hole. So transformation of stars is like that way around. It is mentioned red giant, white dwarf, and black dwarf. This is what is mentioned over here, right? And transformation of stars also like red supergiant and supernova, neutron star, or black hole. So this depends upon the amount of mass that is inside the star. White dwarf, what is white dwarf? White dwarf, this is a very small hot star, the last stage in the life cycle of a star, like the sun. White dwarfs have a massive, smaller, white dwarfs have a mass similar to that of a sun. Means once it is a white dwarf, it will have a mass similar to that of a sun, but only 1% of the sun's diameter. It will have only 1% of the sun's diameter, approximately the diameter of the earth. A supernova, this is the explosive death of a star. When the explosive death of a star happens, this is called supernova, and other results in the star obtaining the brightness of 100 million suns for a short time. And that will create a brightness of around 100 million suns for a very short time, and that will create a phenomena called supernova, right? So now the universe and everything will be coming into this part, like supernova. Supernova type 1 is like these occur in binary stars in which gas from one star falls into a white dwarf, causing it to explode, right? This is the first part. And type 2 is like these occurs in stars 10 times or more as massive as the sun, which suffer runaway internal nuclear reactions at the end of their life, leading to an explosion. They leave behind neutron stars and black holes. Supernova are thought to be the main source of elements heavier than the hydrogen and helium. So supernova is the main source of elements which are like also means heavier than hydrogen and helium. Means the elements that are created, they are created from supernova. So there are this two type of supernova that is mentioned over here. Means one in binary system in which gas from one star falls into a white dwarf and it is exploding, and next one is like massive as the sun, run away from internal nuclear, that is from the internal nuclear reactions which is happening at the end of their life, and that is creating the explosion, and they are leaving behind like neutron stars and black holes. And this supernova is the main source of element for hydrogen and helium. Now we are coming into neutron stars. These stars are composed mainly of neutrons and are produced when a supernova explodes, right? Facing the protons and electrons to combine to produce a neutron star. So forcing the protons and electrons to combine to produce a neutron star. They are basically composed of neutron, and when a supernova explode, it is protons and electrons are combining to produce a neutron star, right? Typical stars have a mass of 3 times the sun. So typically a star have a mass of like 3 times the sun, but a diameter of only 20 kilometers. But the diameter is very less, right? Mass is enormous, but the diameter is very less. If its mass is any greater, its gravity will be so strong that it will shrink further to become a black hole. Means if the mass is greater, then the gravity of the star will be so strong, then it will shrink further to become a black hole. Pulsars are believed to be neutron stars that are very spinning very rapidly. Black holes, these are believed to form the massive stars at the end of their lifetime. At the end of the lifetime, black holes are created. The density of matter in a black hole cannot be measured. We know this, like density of a matter in a black hole cannot be measured. Like once anything enters into a black hole, that is converted into energy. So these things are like also we have seen in movies, like in means anything whenever a spaceship or a person is coming closer to the black hole, also then also time is shifting and all. These are shown in movies in Hollywood and all. So this is the concept. The gravitational pull in a black hole is so great that nothing can escape from it, not even light. It can often engulf neighboring matters, including stars and planets, etc. So this is what is the gravitational pull of a black hole is so strong that it can nothing could escape. It means light could also not pass through a black hole. It can often engulf neighboring matters like stars and planets. It can also means if a star or a planet is also pulled into it, it will be gone in a means in a blink of an eye, or it is something can be mentioned that way around, right? And black hole and gravitational waves, when two black holes orbit each other and merge, it could cause ripples in space. These ripples would spread out like the ripples in a pond when a stone is tossed in it. Like when two black holes are like orbiting each other, they will create a wave and all. Scientists call these ripples of space gravitational waves. Yes, this is what is mentioned like gravitational waves. And gravitational waves are invisible. These are invisible. They travel at the speed of light, that is 1,86,000 miles per second. This is what is the speed of the light, right? First observation of gravitational waves was made September 14, 2015 at LIGO. And Chandrasekhar limit, we have discussed it in an earlier class also. This is the Chandrasekhar limit. This is implied for masses above 1.44 solar masses. There could be no balance between electron degeneracy and the crushing gravitational force, and that the star would continue to collapse. So the calculation of the maximum mass of 1.44 solar masses for a white dwarf was done by Subramaniam Chandrasekhar. So this is a special unit that is created by the scientist named Subramaniam Chandrasekhar. And Chandrasekhar limit is basically this. Like this is implied that for masses above 1.44 solar masses, means 1.44 solar masses and above, and there could not be any balance between electron degeneracy and the crushing gravitational force. So that collapse will, until it is stopped by neutron degeneracy with the formation of a neutron star. But even that is not the ultimate limit, since neutron degeneracy can also be overcome by masses greater than the solar masses, and the ultimate collapse is towards a black hole. So this Chandrasekhar limit is a totally different unit basically, right? And universe is expanding and all, we know this, and it is like average temperature of the universe is now only 2.725 Kelvin. Average temperature is like 2.725 Kelvin. As the time grows, the universe is cooling. At present, the cooling and marching towards a big freeze known as the heat death. When the universe will be devoid of any unstable heat energy, such prediction is supported by measurements which are done by Wilkinson Microwave Anti-Anisotropy Probe (WMAP) on the current geometry and the density of the universe. Right. So this is what is at the current scenario. This is means proposed. The universe like a spans a diameter of over 150 billion light years, and is flat, not spherical. It is flat, but it is not spherical. The universe is ever expanding, and the having no center, as each galaxy is away from one another. And it is 150 light years means the total diameter, and it is ever expanding, and it is having no center. Some scientists predict that such expansion may fade with a radically catastrophic end in a big rip, that everything will be forced to be ripped apart. So this is also something that some scientists are like speculating and all, like it may become such a big expansion that radically catastrophic ending, and that will be a big rip. Our changing view of the universe, like 2000 years ago, the Greek astronomers thought that the Earth was at the center of the universe, and the moon, the planet, the sun, and stars are orbiting around it. In the 6th century, it was like Aryabhatta who stated that the rotation of the heavenly bodies as observed by us is due to the rotation of the Earth around its axis. So that is first Aryabhatta has proposed, like it is not that the sun is orbiting around the Earth, it is the Earth is orbiting around the sun, and this is the other planets are also doing the same. Aryabhatta discovered that the day and night are occurred due to the rotation of the Earth. He also established that the lunar and solar eclipses were caused due to the shadows of the Earth and the moon respectively. In the 15th century, Nicolaus Copernicus, the Polish scientist, shows that the sun was at the center of the solar system and planets revolve around it. So it was basically not Aryabhatta. Aryabhatta's concept was given like Earth is rotating and all. And then Nicholas Copernicus, the Polish scientist, uh, he showed that the sun was at the center of the solar system, and the planets are basically revolving around the uh, sun. So the sun becomes the center of the universe. In the 16th century, similarly, Johannes Kepler discovered the laws of planetary orbits. This was discovered by Johannes Kepler, and but the sun still remained at the center of the universe. It was only in the beginning of the 20th century that a clear picture of galaxy became clear. The sun was found to be located in a corner of the galaxy. So, but in the recently in 20th century starting, it was mentioned like sun was found to be located in the corner of our galaxy, right? So this is the latest finding. This is what is we are believing at present. Like also in 2016 February, scientists from Laser Interferometer Gravitational Wave Observatory (LIGO), that is why we have what we have referred earlier, revealed that they had detected gravitational waves. Previously, gravitational waves had only been understood indirectly via their effect on the timing of pulsars in binary system. In first proposed in 1960 by Albert Einstein, gravitational waves are ripples in space and that are produced when black holes collide and stars explode. So what was referred back in 1916 by Albert Einstein, that gravitational waves will happen mathematically. So these things are also observed in February 2016. Like when two black holes are colliding, these gravitational waves are created. These waves, scientists hope to gain valuable insights into the universe because these waves experience no barriers like electromagnetic waves such as radio waves, visible light, infrared light, X-rays, and gamma rays. So these waves are not having any no barriers are there. Like there is no electromagnetic wave or radio wave or visible light, infrared light, X-ray or gamma rays are there. So when two black holes are colliding and all, these gravitational waves are means these are observed in February 2016 by LIGO, right? So laser interferometer or gravitational wave observator LIGO in India. LIGO India, this is a specific branch which is having in India. This planned a collaborative project between a consortium of Indian research institution and LIGO laboratory in the USA, along with its international partner Australia, Germany, and the UK. So the LIGO project operates 3 gravitational wave detectors. 2 are at Hanford and 1 at Livingston in USA. The proposed project aims to move one advanced LIGO detector from Hanford, USA to Hingoli in Maharashtra, India. Gravitational waves are distortion or ripples in the fabric of space-time caused by some of the most violent energetic processes in the universe, right? This is what is mentioned over here again. So this means space-time is also very interesting and all. Albert Einstein have mentioned all these things. If space and time is like, if you consider like the universe to be a piece of cloth and time to be a like a ball of steel ball and all. So if we are like putting the ball into this universe which is a cloth and all, so the cloth will definitely dip and there will be the change of like shape of the cloth and all, and that way around space and time means this is uh, means related that way around, right? So that is also mentioned over here. Solar system is dominated by the sun, which we all know, like which accounts for almost 99% of the matter of the whole system. 99% of the matter is basically accounts for basically is the sun. It is the source of light and heat to us. Source of light of heat. We all know this. Scientists believe that the sun has been formed from a moving cloud of gases, which is called nebula. Scientists believe that it is from a formed from moving cloud of gases, and it is called nebula. The sun and the planets were born out of this cloud. The force of gravity has created them. For over millions of years, these balls of dust and gas are moving around the sun. The sun, by virtue of its mass and weight, controls the movement of the planet. This force is called the force of gravity. So this is what is force of gravity, right? Sun is at the center of the solar system with 8 planets. That is, there are like 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and their satellites, dwarf planets, asteroids, meteors, and comets that move around the sun. This is entirely which is our solar system. So there is no mention of Pluto, and this is what is mentioned over here. Like till 2006, there was 9 planets in the solar system. Pluto was the furthest planet from the sun. In 2006, the International Astronomical Union (IAU) adopted a new definition of planet. Pluto and other celestial bodies like Ceres 2003 UB does not fill in this definition. It is no longer considered as a planet of the solar system. So that is from 2006 and onwards. It is Pluto is not considered. So there are like at present there are 8 planets, right? This is the sequence in which it is lying from the sun. It first is Mercury, then is Venus, then is Earth, then it's Mars, then is Jupiter, then Saturn, then Uranus. Like the sun. The sun, it is believed that the sun was born about 5 billion years ago. Since that time, it is continuously emitting huge amount of heat and light, and it is expected to glow in a similar manner for the next 5 billion years or so on. The sun is nearest star from us. The nearest star from Earth is like it is sun. The sun is the source of almost all energy on the earth. In fact, the sun is the main source of heat and light for all the planets. And the radius of the sun is almost 100 times of the radius of the earth. And the mass is a million times the mass of the earth. Like 100 times more is the radius from the earth, and mass is like million times the mass of earth is what is basically is the sun. The sun is essentially a sphere of hot gases, and it is the disk is also called the photosphere. The layers of gas above the photosphere are extremely hot, but their densities are extremely low. These layers are very faint and not visible in the presence of strong light from the disk of the sun. And now we'll be like looking. Basically, we would not go into this details of like everything. So solar flares are charged particles, and solar flares reach the atmosphere. Basically, these effects are shown like aurora australis and in North Pole aurora borealis. So these are called solar flares. The solar flares, when they are reaching, so we see this beautiful phenomena, which is basically we can see. And also there is the effect of corona also, and this is also a similar kind of a layer. It appears like a crown around the sun. Outermost layer is visible, and it appears like the it is called the corona, right? And it is the sun's disk is completely cut off, and the crown and the sun, this layer is basically called the corona, and which is visible. And that way also we have discussed like this aurora australis and aurora borealis, all these things happens. When it happens is it is because the sun, there is a solar flare, these are reaching into the atmosphere. Solar flares, these are charged particles which are coming from the sun's gravity into the outer space, right? So this is aurora borealis. This is something beautiful blue white kind of a light that is being seen when people travels to part of like Canada and like near to North Pole and all. These aurora borealis phenomena can be observed from there also. These are happening because of solar flares. And corona is also the crown kind of thing that is on the sun. Outermost layer becomes visible, and it is called the corona, right? The temperature of the bright disk is about 6000 Kelvin at the center of the sun. The temperature is about 15 million Kelvin. The pressure is also extremely high. All these conditions are right for fusion reactions. In the sun, 4 protons, nuclei of hydrogen atoms, combine to form a helium nucleus, right? These are forming a helium nucleus in the sun. The mass of the helium nucleus is slightly smaller than the combined mass of 4 protons. So there is the loss of mass in the process. This loss of mass is the source of sun's energy. So that way around, like the pressure is also extremely high. All these conditions are right for fusion reaction. So this fusion reaction, 4 protons, nuclei of hydrogen atom combine to form a helium nucleus. The mass of the helium nucleus is slightly smaller than the combined mass of 4 protons. So that is the loss of mass in the process, and this loss of mass is basically the source of sun's energy. Sun is about 150 million kilometers away from the earth, and light travels at a speed of 3 lakh kilometers per second. So the light of the sun takes about 8.3 minutes to reach us. Like what is the time that it's taken from the sun light to reach the earth? It is 8.3 minutes, right? 8.3 minutes is the time. The light of the nearest star, Proxima or Alpha Centauri to the sun, reaches Earth in about 4.3 light years. Nearest star, Proxima or Alpha Centauri, this light reaches from like 4.3 light years. In August 2018, NASA has launched first planned robotic spacecraft to study outer corona of the sun. We all have seen it in the news, like NASA has launched this first planned robotic spacecraft. The goal of the probe is to determine structure and dynamics of the magnetic field at once at sources of solar wind. It will also trace flow of energy that heats corona and accelerates solar wind. Process of fusion. So this is what is according to Einstein's equation, E is equal to mc square. E is the energy and m is the mass. The quantity c is the velocity of light. So this is what is the most important equation. So E is equal to mc square is like according to Einstein equation is the energy produced when a mass is lost. When a mass is lost, this is the energy is produced. E is equal to mc square. Most stars produce the energy by the process of fusion. Most stars are producing energy by the process of fusion only. The planets. Now we have the planets. Planets are actually revolving around the sun. They have their own elliptical path of movement known as orbits. Movement around its own axis is called rotation. When it is rotating around its own axis, it is called rotation, and also when it is rotating around the sun, it is called the revolution. they have their own speed also. They having their own speed. Planets, unlike stars, have no light or heat or of their own. Planets are having no light or heat of their own. They are lit by the light of the stars. They are basically lit by stars. Stars twinkle, whereas planets do not. We all know this. And the word planet comes from the Greek word planetae, which means wanderers. Planets keep changing their positions with respect to uh, with respect to the stars. The planets are keeping changing position with respect to the stars. And inner and outer planets, the first four planets, namely Mercury, Venus, Earth, and Mars, much nearer to the Sun, means which are much nearer. These are called inner planets, and the inner planets are very few moons. So Mercury, Venus, Earth, and Mars, they are having very few moons. Are they are what they are having. A planet outside of Mars, namely Jupiter, Saturn, Uranus, and Neptune, are much farther off than the inner planets, and they are called outer planets, right? So these are closer to the this one first four is like closer to the sun, and next four is like which is much away from the sun, and these are called outer planets. They have a ring. These outer planets are having a ring system around them. The outer planets have more number of moons. The outer planets are having more number of moons, right? Inner planets are having less number of moons, and the outer planets are having more number of moons. Terrestrial and Jovian planets, Mercury, Venus, Earth, and Mars are also called terrestrial planets. Mercury, Venus, Earth, and Mars, they are called terrestrial planets because their structure is similar to the Earth. Mercury, Venus, and Mars, they are having the structure is basically similar to the Earth. The common features of this planet, they are having this common feature, that is a thin rocky crust, a mantle rich in iron and magnesium, a core of molten metals, and have thin atmosphere. The planet outside the orbit of the Mars are called Jovian planets because their structure is similar to that of Jupiter. Means apart from these four planets, the other planets, they are having a similar kind of a structure which is that of a Jupiter. The common feature of these planets are like they are gaseous bodies. Like these other planets, outer planets are basically they are formed of gas. They have rings. They have rings which are belts of small debris around them and have large number of satellites. They are having huge number of satellites, the outer planets, right? So there is a particular difference between the inner planets and the outer planets. Inner planets are basically these are like not made of gas and all, whereas the outer planets are basically they are basically gaseous, and they are basically made up of gas and all, right? And Mercury is like Buddha. It is called. It is the nearest to the sun. It is the smallest planet of the solar system and nearly the same size and mass of the moon. It is just similar to the size of the moon. Mercury takes 88 days for one orbit around the sun and 59 days for one spin on its axis. It spins in its own axis for like 59 days, and 88 days it takes to orbit around the sun. It has no satellite. Mercury has no satellite. And there is no atmosphere on Mercury. The surface of Mercury is rocky and mountainous. One side of the surface facing the sun receives maximum heat and light. The surface of this planet does not receive sunlight or heat on this other side. On part of Mercury, therefore, this is very hot, while the other part is very cold. Only one part receives the sunlight, right? And it is rocky and mountainous, and there is no atmosphere. This is the most important thing. Like there is no atmosphere in any other planet in the solar system, so that is why the Earth is the only place where life and the form of life can sustain. As Mercury is very close to the sun, it is difficult to observe it, as most of the time it is hidden in the glare of the sun. However, it can be observed in September and October just before sunrise in the eastern sky as a morning star. It is also seen in the western region of the sky immediately after sunset in March and April as an evening star, right? This is also visible in means observed in this time only. On Venus, this is called Shukra. Venus has no moon or satellite of its own. It rotates on its axis. Is somewhat unusual, that is from east to west. It rotates from east to west. Its size is nearly the same as that of Earth. Venus and Earth size is more or less the same. The mass of Venus is nearly 4-5 times that of the Earth. It means mass is much higher. It takes 24.7 days for one orbit around the sun. It takes around 24.7 days for one orbit around the sun, and 243 days for one spin on its own axis. On its own axis, it takes like 243 days, and to spin one orbit around the sun, it takes around like 224.7 days, right? And now we are seeing like Venus is basically made of carbon dioxide and all, and the cloudy atmosphere of Venus sends back the cloudy atmosphere of the Venus. Now, the cloudy atmosphere of Venus sends back almost 3/4 of the sunlight that falls on it. So that is how Venus is made of. And because of thick toxic atmosphere which is made up of sulfuric acid clouds, it is an example of extreme greenhouse effect. It is hottest planet in the solar system. So which is the hottest planet? Hottest planet is Venus. Venus is the hottest planet in the solar system. And sometimes Venus appears in the eastern sky before sunrise, and sometimes it is in the western sky just after sunset. This is called a morning or an evening star also. And Goldilocks zone is the area of space in which a planet is just in the right distance from its home star, so that is surface is neither too hot or not too cold. The Earth occupies what scientists somewhat call the Goldilocks zone. So that Earth's position is in the Goldilocks zone. It's not that much hot or that much means cold and all. So liquid water, key ingredient for life, right? Just because a planet or moon is in the Goldilocks zone of a star, it doesn't mean it's going to have life or even liquid water. So that is also not like if it is in the Goldilocks zone, they will definitely be having life or water. Venus and Mars are also in the habitable zone, but aren't habitable because of lack of atmosphere. Like Venus and Mars are also in this habitable zone also, but they are not habitable because there is no atmosphere and solidified core, and the core is also not solid in both Venus and Mars. We know like NASA sent like expeditions, cameras and all to the Mars, but finally it has been observed and all that there is no atmosphere, and without atmosphere there is no possibility of life. The Earth, this is our planet, the Earth. Our Earth rotates from west to east. Earth is more or less like a sphere. It is more or less like a sphere. It is slightly flattened in the north and in the south. And it is somehow it is like described like it is in the shape of an orange and all. It is slightly flattened in the north and south. The Earth is best to be described as a geoid, which means Earth-like shape. Earth is the third planet, third nearest planet to the Sun. In size, it ranks fifth. In size and makeup of the Earth is almost identical to Venus. More or less, it is identical to Venus. Due to presence of water and land masses, the Earth appears blue-green in color from the space. Therefore it is called blue planet. So, which one is called a blue planet? Earth is called a blue planet. Because of the availability of water and land masses. The Earth is the only planet where some special environment conditions are responsible for the existence and continuation of life. So Earth is the only planet because of some special environmental condition, and we all know this, right? And our only natural satellite, the moon, and moon is our only natural satellite. Planets are satellites, and we all know this. Like, and the phases of the moon, bright part of the moon is seen during a month, are called the phases of the moon. Like there are bright part and there are dark part. The moon takes almost like the same time, 27 days and 7 hours to complete both the movement, the rotation, revolution. But they always present the same side towards our Earth. The moon has no atmosphere. The moon is also having no atmosphere, right? There's no atmosphere. There is no atmosphere also in the moon, and it takes like 27 days and 7 hours to complete both the movement. That is rotation and revolution, both are completed in 27 days and 7 hours. So like this is what is like the diameter of the moon is only 1/4 of the Earth, and moon is 38400 kilometer, 384,400 kilometer away from the Earth, and the light reflected from the moon reaches us in just 1 and a quarter second. It is just reaching in 1 and a quarter second, and this is like Neil Armstrong, Edwin Aldrin, and Collins. They set foot and they first time they went to the moon in like 21st July 1916. They found the moon's crater is dusty and barren. What they found was like moon's crater surface is dusty and barren. There are many craters on different sizes. It is also a large number of steep and high mountains. These cast shadows on the moon's surface, and this is what is creating the shadow of the steep and high mountains and all. And Mangal is called Mars. It is almost half the size of the Earth. The diameter of the Mars is slightly more than half of the Earth, but its mass is only 1/10 of the Earth. Right? Its mass is very much lesser, 1/10 of the Earth. And it takes 687 days for one orbit around the Sun, and 1 day for one spin on its own axis. 1 day it takes to spin around its own axis, and 687 days to orbit around the Sun. The atmosphere of Mars is much thinner than that of the Earth. The atmosphere is much thinner. It perhaps contains many nitrogen and argon. There is no oxygen and all. That is what animals and human being and all could not survive. In Mars and all, it probably consists many nitrogen and argon. Traces of oxygen have also been found. Only traces of oxygen have been found. It appears slightly reddish, and therefore it's called red planet. So blue planet is Earth, and this red planet is like Mars. There is two natural satellites in Mars. These are like Phobos and Deimos. In July 2018, scientists revealed that they had found evidence of a liquid lake beneath the surface of its southern pole's ice cap. 2018 it was believed that a liquid lake has been discovered. Mars is visible from the Earth for most part of the year. Most part of the year it is visible. However, it is situated for observation. It is in opposite the sun's position in the sky with respect to the Earth. On this day, it is closer to the Earth as well. So this is what is completing the Mars. And the Jupiter is the largest planet in the solar system. 11 years and 11 months for one orbit around the Sun, and 9 hours 56 minutes to spin around its own axis, right? And it is the largest planet. 67 satellites, it is having 67 satellites. It is also faint rings around it. We know that there is rings around Jupiter. I believe there is a complex storm in the atmosphere of the planet ranging for a few hundred years. And it is also believed like for few hundred years is a complex storm that is in the atmosphere of the Jupiter. Its mass is more than the combined mass of all other planets. If you combine the mass of all other planets, this mass of Jupiter is more than all other planets also. Because of its large mass, Jupiter exerts a strong gravitational pull on the other objects which pass by it. A comet passing close to it is likely to experience this pull and stay from its original path. In 1994, the comet Shoemaker-Levy also broke into several pieces when it came near to the planet. The pieces then collided with the planet. So this is what happens when a comet comes in closer to the Jupiter because of its huge mass. There is huge gravitational pull also. And similarly, this is what had happened in 1924. The comet Shoemaker-Levy actually broke into several pieces when it came closer to the planet. Jupiter's bright appearance in the sky after Venus and occasionally Mars is due to the thick atmosphere and reflects most of the sunlight falling on it. It is believed that Jupiter mainly consists of hydrogen and helium in gaseous form. Basically, the gas is formed of hydrogen and helium. Its cloud-like outer region consists of methane in gaseous form, while ammonia is present in the crystalline form. Outer regions consist of methane in gaseous form, and ammonia is present in the crystalline form. That is in Jupiter. The next planet is like, and Jupiter is like, and there is Saturn. So Saturn is also it is similar in mass and composition to Jupiter, however cooler than the Jupiter, and that is also like what is important about Saturn also. And Saturn is like beyond Jupiter. Saturn, which appears yellowish in color, it appears yellowish in color. For this yellowish color, it is like a unique in the solar system, and it orbits around the sun in like 10 hours 40 minutes for one spin on its own axis. And it is also especially because this is what is like 10 hours 40 minutes for one spin on its own axis, and it has 62 satellites, and it takes like 29 years 5 months for one orbit around the sun, and it like 10 hours 40 minutes for one spin around its own axis. And it is yellowish in color, and it is dense among all planets. Saturn is the least dense. It is least dense. Dense is less than that of water. Its density is less than that of water. The density of Saturn is less than that of water also. It is similar in mass and composition to the Jupiter. Saturn is similar to the mass and composition of Jupiter. It is however cooler than Jupiter. However, it is cooler than Jupiter, right? Now it is the Uranus. Uranus, it was the first planet to be discovered with the help of a telescope. First planet discovered was Uranus. William Herschel discovered the planet in 1781. Hydrogen and methane have been detected in the atom of Uranus. In the atmosphere of Uranus, we found hydrogen and methane. Except Venus and Uranus, all other planets rotate in the same direction in which they revolve. Except Venus and Uranus, means all other planets are revolving in the same direction in which they revolve. But Venus and Uranus, they are rotating in the opposite direction than in the direction that they revolve. Like Venus, Uranus also rotates from east to west. That is what is mentioned. Like Venus also rotates from east to west, and Uranus also rotates from east to west. Where Earth and other they rotate from west to east. The most remarkable feature of Uranus is that it has highly tilted rotational axis. It is having highly tilted rotational axis. As a result, in its orbital motion, it appears on the roll on its side. It takes 84 years for one orbit around the sun and 17 hours 14 minutes for one spin on its own axis. It has 27 satellites. 27 satellites are around the Uranus also. And Neptune, it is also called Varun. This satellite was discovered by Sir William Herschel on the basis of the law of gravitation given by Sir Isaac Newton, which he gave almost 180 years before it. It takes 165 years for one orbit around the sun and 16 hours 7 minutes for one spin on its own axis, right? Uranus and Neptune are quite faint and cannot be seen with naked eye. That is why 6 planets were known in ancient times. These 2 planets have been discovered. Only telescope was discovered. It has after telescope, it was like 8 satellites. It was like only discovered this Uranus and Neptune. Previously there were 6, and now after the discovery of telescope, it is like 8 planets are there. Uranus and Neptune are also discovered, right? And Pluto is not in the consideration zone, so we should not be devoting anything for Pluto and all, because Pluto is not considered at present. So the boundaries of the solar system, the orbit of Pluto does not mark the boundary. It extends much beyond of it. The size been estimated is like 105 AU astronomical unit, which is equal to the mean distance between the Earth and the Sun. In the mean distance of the Earth and the Sun, like after Pluto, that is what is the boundary of the solar system. And the age of the solar system, there exist billions of very small objects. The age there are very billions of small objects are there. These objects are found very early in the gas cloud from which the solar system evolved. Occasionally, parts of these bodies are disturbed by accidents, such as star passing nearby, causing them to move towards the sun, which appears as comets. Comets are of great interest to scientists because material of comet presents a sample of the original material from which the solar system was formed. From the material of the comet, the original material from which the solar system was formed could be found, right? And asteroids, star-like, these are numerous tiny heavenly bodies between the orbits of Mars and Jupiter. Asteroids can only be found between the orbits of Mars and Jupiter, which revolve around the Sun. These bodies are called asteroids. Each asteroid has its own orbit, and orbits, all of them, are spread over a large distance, forming a band. A few asteroids have elongated orbits, going beyond the orbit of Jupiter. The size of asteroids varies from a pebble. Size of asteroid can vary from a pebble to a few hundred kilometers also. So the largest asteroid is Ceres in the diameter of about 1,000 kilometers. Scientists believe that asteroids are the pieces of matter that somehow could not get assembled in the form of a planet. When it could not get into the form of planet, these asteroids have been formed. Asteroids are small rocky bodies. Basically, these are small rocky bodies that are rotating, means that are in our solar system. While making their rounds, the asteroids often collide and break into smaller pieces. These smaller pieces of meteoroids sometimes fall on the Earth. You know, the smaller pieces of meteoroids, they also sometimes fall into the Earth. They crash into the ground and create craters. Meteor craters in Arizona, USA, and Lonar Lake in the state of Maharashtra, India, are good example of craters. Like when these asteroids have struck and it has created a impact and their crater have been created. So both these craters means in Arizona and in the Maharashtra, these craters have been created. These are there. Like comets, like it is also revolves around the sun in highly elliptical orbit. However, their period of revolution around the sun is usually very long. They become visible from the earth only when they come close to the sun. A comet appears generally as a bright head with a long tail. Comet is having a bright head with a long tail. We know this, like comet we have seen in the very rarely in the night sky and all. The comet appears generally as a bright head with a long tail. The length of the tail grows in size as it approaches the sun. The tail disappears again. The comet moves away from the sun. The tail of a comet is always directed away from the sun. So this is what is comet. So we discussed like asteroids and comets and like boundary of the solar system. And many comets have been like in the 76 years to last in 1986. The study of comet tails has shows the existence of molecules of carbon, nitrogen, and hydrogen. The molecules of carbon, hydrogen have been present in comet. Since this molecule can help to form complex molecules necessary for the origin of life, some scientists have suggested that the seeds of life on the earth are brought by comet from the outer space. This is also been thought like from outer space, the comets have brought the seeds of life on the earth. This is also been mentioned and prescribed and all. Meteors, meteorites, and meteor showers. Like meteors are very small. Meteors are very small stone-like objects that are revolving around the sun. Their existence become known only when some of them occasionally enter the Earth's atmosphere. Some entering the Earth's atmosphere only we can know what is a meteor, right? At the time it is a very high speed only entering into the Earth's atmosphere. Due to the friction in the atmosphere, it heats up, glows, and evaporates quickly. The path of the meteor therefore appears as a bright streak of light. The bright streak lasts for a very, and these are called as shooting stars. So these are what is a shooting star. Very rarely we find a shooting star, and this is what is a meteor, right? It enters into the atmosphere, it starts destroying, and then it is destroyed until and finally it is reaching our means the surface of our Earth. Some meteors are large and they can reach the Earth, but some can also reach the Earth before they evaporate completely. The body that reaches the Earth is called a meteoroid. When it reaches the Earth, it becomes a meteoroid, right? They can be examined in the laboratory, and when the Earth crosses over comets, once the meteors are seen, these are no meteor shower. Some meteors occur at regular intervals. New discovery of explanets are all. These are not that important and all, and like there is like expo on 7th of June 2018, scientists working in physical research laboratory using the PRL advanced radial velocity and all. They have spectrograph integrated telescope in Mount Tabu, and the discovery of host star like EPIC 2119452001 and exoplanet EPIC. These are like discovered, which are like 600 light years away from the Earth. These are like also been discovered in 2018. So this is what is like the basically the topic like at solar system and our universe and solar system. And like now few of the questions, if you can just want to have a look. Which of the following statements are helping in probing the Big Bang theory? Study of cosmic microwave background radiation CFBR, measurement of Wilkinson microwave anisotropy probe, redshift observation, information of large hadron collider, right? So in this case the correct answer is like D is the correct answer, right? So D is the correct answer. All of this is the correct answer. And consider the following statement regarding solar system. All the planets constitute less than 2% of the total matter of solar system. All the Jovian planets have rings. All the age of the solar system, there are numerous small celestial bodies. Which statements are correct? So this is also, I believe, D. Yes, D is the correct answer. All of those. We have just covered it. Like this is all of those. And consider the following statement. Our galaxy Milky Way, spiral galaxy, solar system located in approximate center of the Milky Way. Which statement is correct? This also like only one statement. Our galaxy Milky Way is a spiral galaxy, right? Which of the following statements are correct? Most of the stars in our universe exist single. Huge mass stars has shorter duration of lifespan. In future, sun may become a black dot, not a black hole. Chandrasekhar limit deals with the finding of black hole. So in this question also 4, this is like C is the correct answer. C is the correct answer. C is the correct answer means only high mass stars has shorter duration of lifespan, and in future sun may become a black dot, not a black hole. These are the two correct statements. So number 5 is like, consider the following statement regarding Mercury. One of the largest one part of planet is very hot while other is very cold. It is true. Its surface rocky and mountainous is true. It is seen in the sky in September, October just after sunset. So this is also this is not true. This is 5 is A. These two points are correct. 1 and 2. Consider the following statement about Pluto. Pluto is the largest dwarf planet of solar system. Pluto is located in Kuiper belt. Pluto has no satellites. So this is like only which statement is correct? Only only two. Only two is correct. Only two is correct. Only two is correct, right? Only two is correct. And then consider the following statement: pulsars emit regular pulses of electromagnetic waves. Quasar emits radiations. Origin of stars are traced back to nebula. It is predicted that after 5 billion years, the sun may expand enough to engulf all its planet and collapse itself. So, which statement is correct? This way around, you also will check. D is correct. All of these are correct. All of these are correct. The measures of astronomical distances, light year, astronomical unit per second, orbital length. So this way around, I quiz now 1 and 2 will be the correct. A will be the correct. So 8 is like no 8 is like B is the correct one. 1, 2, and 3 per second is also this is the correct answer. B is the correct answer. B, right? B is the correct answer. 1, 2, and 3. Consider the following statements regarding moon of the earth. In terms of size of the moon is smaller to the planet Mercury. In terms of mass, moon is about 2/3 of the planet of Mercury. I believe like it will be number 1 will be the correct answer. Let's see. 9 is A. Yes, 9A is the correct answer. Only one is the correct answer. And like then another question we will see, which when a star moving away from the observer then the light coming from it looks red gradually shifting from white. The observation is useful to explain its origin of the universe. So which statement is correct? And it is like A is correct. Only one. When a star moving away from the observer, then the light coming from it looks red gradually shifting from white. It starts looking red, gradually shifting white. This observation is useful to explain the origin of the universe? No, this is not correct statement. This is the only correct statement, right? And 11th is like, which of the following statement is a correct? Supernova is a stage when stars explode and cause its characteristics. Stars have similar mass like Earth or Sun, have similar rotational speed. Stars have mass lower than the Sun, never explode. Once a star turns to white dwarf, it is rapidly converted to black hole. Which statement is correct? Only one. 11 is like 8, only one. This statement is only correct. So this statement is correct, like supernova is a stage when star explode and cause its characteristic. This is the stage when the star is exploding and the characteristic is it is bringing up the characteristic also. A star's mass is not similar to sun. A star lower than the sun, never explode. No. When the star turns to white, it is rapidly converted to black hole. No, this is also not correct. So that's it, that is the video. The video is like more than 1 hour also, so definitely I will be bringing more videos and all. So definitely like the videos, share the videos, and subscribe to my channel, and definitely keep watching my videos, and I'll be bringing in more videos for the purpose of education and other contents also. So bye bye for the time being. Have a great day everyone, and definitely stay tuned for new upcoming videos, and do definitely subscribe to my channel, and do definitely like the videos, share the videos to the one who are like willing to means receive more and more contents like educational contents and other contents, and like discussions and interactions, and definitely do comment, and definitely do share your views also, and do also like interact in the comment sections, and definitely subscribe to my channel. Bye bye for the time being. Do like, share, and subscribe. Bye bye.